Welcome to Fukushima, 1 year later. An inquiry in the events of March 11, 2011. We are very pleased to have with us today on the traditional lands of the Coast Salish, Audrey Rivers from the Squamish Nation to give us a blessing to begin our event.
Honored guests, participants of the Fukushima nuclear disaster 1 year later, before I begin my opening prayer, I ask you all to stand for 1 minute of silence for the lives lost 1 year ago today. I ask you all to pray in your own way. Thank you. I welcome you all to Sailors Territory. Vancouver is surrounded and shared by 5 Coast Salish nations. To the east, we have the Stolo and the Simon Fraser. We also have the Katy people in the Coquitlam area. And to the south, we have the Tawasin in the Ladner area. And to the west, we have the Musqueam in the UBC area of Vancouver. And to the north, we have the Squamish, to which I belong. We have the Dusselwood as well, which is just across the Burrard Inlet. Both villages in North Vancouver. My ancestral name is Teotalo, named after my great-great-grandmother, which is a Squamish name. My English given name is Audrey Rivers, elder of the Squamish Nation. I reside on the Aslan Reserve in North Vancouver. Today, I honor the 3 generations of the past, present, and future. I firstly honor and pay homage to all the people who lost their lives in Japan 1 year ago today. I pray for our ancestors. Because of them, we are all here. I also pray for our past leaders and our families. Today is the 1 year anniversary of the tsunami. We offer a prayer for the people in Japan, for the families that are enduring grieving. I ask them Chesiam. Chesiam means the Creator, the Great Spirit, the Lord, the Abba, the Allah. I ask for the Chesiam to continue to watch over them. I pray for the President and give thanks to the Great Spirit for this day to bring you all here for this gathering. A day of remembrance. I ask the Creator to bless this day, to bless each and every one. I pray for the future, our children, who will one day be our leaders, and pray they will have a happy, healthy, and a safe environment. Today we honor the past, we're learning in the present and applying the future. In closing, I thank you for inviting me here to open with a prayer. In closing, I say, with the knowledge and the technology of all you people, all you leaders, Japan will rise again. In Scottish, I say, Cinqueman Tomi din Anhas Square. Cinqueman Tomi din Anhas. I just said, I thank each and every one of you, all my friends and relations, and ask the Creator to bless the remaining part of this day. Thank you. Osiyam Tamakutsi. Thank you.
Thank you very much, Audrey, for that warm welcome to the territory of the Coast Salish. And good morning and welcome to Vancouver and Simon Fraser University to all of you. My name is Tim Takaro. I'm a physician scientist in the Faculty of Health Sciences at SFU. I'm also a member of the Global Physicians for Survival here in Canada and Physicians for Social Responsibility in the United States, both affiliates of the IPPNW, the International Physicians for the Prevention of Nuclear War, and winners of the Nobel Peace Prize in 1985, who helped sponsor this event. We are gathered here on the Pacific Rim of North America to remember and honor our Japanese sisters and brothers who 1 year ago today were struck by the largest earthquake ever observed. 25,000 perished and hundreds of thousands were displaced, with homes and livelihoods torn asunder. To best honor their memory, we thought this effort to better understand and learn from the events that unfolded at the Fukushima Daiichi nuclear facility on March 11, 2011, would be a fitting tribute to these courageous people. Through this inquiry, we hope to gain a better understanding of the impacts on human health and the environment from the disaster. In such a complex event, it is challenging to know where the truth lies in the midst of mixed messages and with great uncertainties still remaining. I will touch on a few key questions that we will examine. What happened at the Fukushima Daiichi nuclear plant on March 11th? And the ensuing weeks afterwards? And what will be the potential health effects? What could have been done to prevent the disaster? Why was communication so bad? What does this event tell us about future nuclear power use, and how does the nuclear fuel cycle relate to ongoing risks of nuclear weapons proliferation? What is the current status of the reactors and their current fragile so-called cold shutdown? It is said that in addition to the 3 nuclear reactor meltdowns, that there was a significant communication meltdown. This was the first disaster of this magnitude broadcast in real time. The broadcasts were not always accurate. Confusion was so great on the ground that much of the city of Nani in Fukushima Prefecture was evacuated into the plume, into the high-dose areas of the plume. On March 15th, the European Union Energy Commissioner described the event using the term apocalypse, while the Japanese government downplayed the risk. Confusion about the status of nuclear fuel in the cooling pools led the US government to issue a much wider evacuation than the Japanese government itself. And some countries evacuated their citizens from Tokyo. How can this confusion be avoided in the future? What is the future of nuclear power? In Japan, which depended upon nuclear energy for 1/3 of its energy needs, 52 of 54 reactors are now idled, and Germany is phasing out nuclear energy completely. Meanwhile, the United States has just issued its first construction permit since 3 Mile Island 34 years ago. Clearly, the public is having second thoughts. And Japan has demonstrated over the past year that even an advanced economy with significant previous dependence upon nuclear energy, can conserve and innovate its way to alternative sources? What will be the fate of Fukushima's so-called gypsy workers? Those itinerant workers who are cycled through the high exposure jobs in the cleanup and exceed their annual dose rates in a matter of days, only to be released back into the ranks of the unemployed. And finally, what does this event mean for the Pacific Rim of North America? This region endured a 9.0 earthquake in 1700. We will have another. Here in Vancouver, we are 425 kilometers from the Hanford nuclear site on the Columbia River, site of the only operating nuclear plant in the region, and home to the largest nuclear waste cleanup project in the world. Are we ready for such an event in our own backyard? In closing, I want to take this opportunity to thank all of our speakers, some of whom traveled great distance and volunteered their valuable time to be with us today. The program committee, whose names you can see on the program, and the sponsors of the event, Physicians for Global Survival, Washington Physicians for Social Responsibility, University of British Columbia, Department of Pediatrics, and BC Children's Hospital, Next Gen University, and the Institute for Neurotoxicology and Neurological Disorders. Finally, the conference would not be possible without the tireless efforts of Yu Yoshida and Jillian Skeet. You, and I think Jillian is probably still out in the registration desk. And the visitors from Japan, Fuyuki Goto, Wataru Iwata, Aya Marumori, Natsuko Yusawa, Yusuke Inchonoke. Please, would you guests from Japan? Thank you so much for your efforts in bringing this inquiry to fruition. And with that, I bring you a taped greeting from Professor Tsunuki Yamashita, the Vice President of Fukushima Medical University. Dr. Yamashita has been the advisor of the Fukushima Prefecture on radiation health effects following the Fukushima event. He took a leave of absence from Nagasaki University to come to Fukushima Medical University in mid-July of 2011. He will lead the Fukushima Health Management Survey of all 2.02 million residents of the prefecture.
Ladies and gentlemen, on behalf of Fukushima Prefecture and Fukushima Medical University, I would like to introduce our ongoing health management survey program in Fukushima, which started last June 2011, just 3 months after the typical Fukushima nuclear disasters had occurred due to the Great East Japan earthquake on March 11, 2011. Taking this opportunity, I first would like to extend our deepest appreciation to the countries, the UN organizations, and other societies for their assistance and solidarity. People living in Fukushima are understandably anxious, especially about potential long-term health consequences for their children. We deeply respect such concern, and we also are strongly motivated to do our best in using the achievements of international science to dispel fears that may be exaggerated or dispelled. At the same time, we must be fully aware of our obligations, our duty to make health protection the principal objectives. Therefore, we have set up the Fukushima Earth Management Survey Program in close cooperation with the Japanese government and the Initiative of Fukushima Prefecture on the basis of Fukushima Medical University, which the Radiation Medical Science Center was newly established on September 1, 2011, especially for this purpose. Our program includes two major parts, the basic survey and 4 detailed surveys, whose detail will be introduced by the Vice Director, Professor Seiji Yasumura, next. Finally, the experience in Japan already provides many examples of relevant public health measures that should be applied for the immediate protection after an accident. We, the Japanese, are also known to be among the most resilient and resourceful in the world. Taken together with your keen advice and assistance from the world, we will surely be charting the best and safest route to Fukushima fully recover. Thank you for your kind support and understanding.
It's now a pleasure to introduce to you the Executive Director of Physicians for Global Survival, Dale Doerr. Dale is a family practitioner who has multiple hats, including Executive Director of PGS. I don't know how many countries you've traveled to in the last year, Dale, to help provide research and support. But we are really pleased to have you introduce our first speaker.
Thank you, Tim. I'm actually going to be introducing 2 speakers, and the next speaker is Dr. Kathy Bacchio. Kathy has a day job. She is a professor of family medicine at London University at Queen's. She's also the author of a very extensive review of all of the Canadian research that had been published up to 2008 on radioactivity and health. Please welcome Kathy back.
Thanks, Dale, and I'm actually really happy to be here today because I think that this topic has been completely under the radar far too much. This was a massive public health catastrophe that maybe got a bit of media attention for a couple of months and then everybody thought it went away. It's been totally ignored really by the Canadian government to the point where just last week the Ontario government has agreed to spend, at this point, I think $600 million to rebuild one of the reactors in Ontario. And the reactor in the Quebec government and New Brunswick government are considering the same. So obviously they haven't got the message and they haven't learned the lessons that the people in Japan paid so dearly for. So I'm going to be speaking to you about radioactivity and health and a bit about the nuclear industry. So what is radioactivity? It's also called ionizing radiation or radiation. How does it affect us? How does it harm us? What does it do to us? And where does it come from? How are we exposed to it? And then a little bit about what goes on inside a nuclear reactor and some of the many very toxic fission products that come from nuclear fallout. There are many, many others, but these are the ones that we tend to measure and tend to discuss, iodine, cesium, and strontium. And then a little bit of the studies that we do have that have looked at the fallout, the health effects of the above ground nuclear testing in Nevada from the 50s and 60s, and some of the studies that have been done elsewhere, and then a little bit about Chernobyl. which probably can be extrapolated to Fukushima, seeing as Fukushima was as serious, if not more serious, than Chernobyl. So what is ionizing radiation? So if anybody remembers their high school chemistry, the periodic table of all the elements, about 100, a little bit more than 100, every atom, every element has have protons which have weight and they're positively charged, and electrons which don't have weight and they're negatively charged. And every atom has equal numbers of each. So they're neutral, the charges, but they also have neutrons which are not charged, and they contribute to the weight. Now, some elements have more than one type of themselves, and they're called isotopes, and the way they differ, they're exactly the same, except they differ in the number of neutrons, so their weight is a little bit different. Some of these are stable, and some are unstable, and we call those radioactive. And what they just have this propensity to sort of fling off subatomic particles, little bits of themselves, or high energy photons, and we call this radiation, or ionizing radiation, or radioactivity. When an element or an atom particle gives off some subatomic particles, we say it decays, and then it actually becomes a different, either isotope or another different element, which itself may be radioactive, and it will continue to drop off these particles, which are called daughters or progeny, until it reaches something that's stable. So an example is uranium-238. So all these all the way down, they're each unstable and radioactive, and they eventually, any one atom of uranium-238 will go down that chain to become lead-206. Now the rest of the bars show what's called the half-life. The half-life of uranium-238 is 4.5 billion years, and that is the time it takes for half of that uranium, say you have a gram of uranium-238, in 4.5 billion years, half of it has become thorium-234. So there's a big range of half-lives. It can be billions of years right down to one of these is actually microseconds. Interesting is radon, which maybe some of you have heard of. Radon is a gas. It's a potent lung carcinogen, and it's actually the cause of lung cancer, the most common cause of lung cancer after smoking. And it's considered to be the cause most of the time of lung cancer that is in non-smokers. And when you disturb rock, the radon escapes, and the Canadian government is actually starting to pay attention to this, and you can actually get a radon measuring kit from Home Depot. Also of interest is the second bottom one, which is polonium-210, which is very, very, very toxic in small doses. And this man is Alexander Litvinenko, who was a Russian spy, KGB spy, who then began to criticize the Russian government. He moved to the UK, and I think it was 2006, died mysteriously of acute radiation sickness, and was found to be polonium poisoning. Still felt to be killed by Russian spies. But anyway, that's a picture of him on his deathbed, and he died within a few weeks of acute radiation sickness. So uranium has three isotopes, 238, 235, and 234. Most of it in the rock is 238. So when we mine it, and in Canada most of that goes on in northern Saskatchewan, a little bit elsewhere, including Ontario, it's like any mine. It's a big pit, and then you take out the rock, and in this case you crush it and try and extract it. We extract out the uranium, and that is what's called yellow cake. What's left is a whole ton of radioactive rubble, pieces of dust. It gets into the air, water, and soil. They pour water over it to keep down the radon gas, and this is what's called tailings ponds. Very polluted, and in this case the pollutant is radioactive. The yellow cake is transported by rail or truck to Port Hope, which is just east of Toronto, where it is refined, and different types of it are made to go into different kinds of reactors. Some of it is sent to the States to be what's called enriched. And the enrichment process basically, the US reactors need more 235 and 238, so it's reversed as to what's natural. So they kind of put it through a filter, and they end up with a waste product of U-238, and this is called depleted uranium, and I'm going to talk a little bit about that later. At this point, I also want to mention that the cost of this to the environment is astronomical, but the cost in money of this whole industry is also astronomical. And this is just a picture, I believe it might be Elliott Lake, which is in northern Ontario, Taylor's Ponds. So what happens inside a reactor? You've got bundles of uranium, and they're called fuel bundles. And inside the reactor, they are bombarded with neutrons. And what happens is it splits apart the atoms, and they release more neutrons, and it becomes a cycle, or I should say a chain. This is called nuclear fission, and it's self-sustaining, and you can't stop it once it starts. In a nuclear bomb, this is what happens, and it's uncontrolled, and you get a massive blast and a huge amount of heat released. Inside a reactor, you kind of moderate this with neutron absorbing and moderating materials, and you're constantly cooling it to control the amount of heat. And that heat is used to boil water, which triggers turbines, which produces electricity. And that's how that works. But really what's happening inside a nuclear reactor is a bomb that's being detonated slowly and in a controlled manner. And you can see what happens when you lose the control. You have an accident. So the fuel rods, I will get into alpha and gamma emission in a minute. The fuel rods are largely alpha emitters, which means the radioactivity does not penetrate your skin, so you can actually handle it. When it comes out the other end, the spent fuel rods are highly radioactive and toxic, with mostly gamma radiation, which is penetrating, so if you go near it, you'll die very, very soon. And it's full of fission products and fragments of uranium atoms, and 200 brand new elements that are not natural. They're human-made inside a reactor. And one of those is plutonium. Plutonium is also used as a fuel in some reactors. So some people will say that, one of the things you can do that's really good about this waste is that you can recycle it. So what they do in a very, very toxic way, they pull out the plutonium, but they're still left with all the rest of the highly radioactive and toxic waste. So it is not any kind of solution to this problem of what to do with the waste. But the other thing about plutonium is that it is what is in a nuclear bomb. So this is the link between the nuclear power industry and the nuclear weapons industry. So acquiring spent fuel is a way to get hold of plutonium. Anyway, the spent fuel rods are so hot, they have to be cooled, constantly have cold water over them for 10 years before they can even be handled to put into dry storage. And as of yet, no one worldwide has ever figured out what to do with this. So it just piles up. Right now, I think in Canada, we have about 40,000 tons just sitting at the reactor site. So what are the health effects of ionizing radiation? Well, there are different kinds. One is what I mentioned, gamma, and that penetrates through you. It's like an X-ray. So it damages the cells on the trajectory wherever it's going, whatever tissue it's going through. But once the exposure stops, the damage stops. That's the good thing about it, if you can say there's anything good about it. Alpha and beta are non-penetrating, meaning you can handle them, but they're what are called internal emitters. So if you ingest them, or you inhale them, or you absorb them through your skin, they get right inside you, and as they throw off those little subatomic particles at high speed, they damage this tissue around where that particle is lodged. Polonium, U-238, and radon are all alpha emitters, and that's why radon is so bad, because you inhale it, and that's what gives you lung cancer, because it lodges in your lung tissue. Strontium, cesium, iodine are all beta emitters, a little bit less damaging, but still internal emitters all the same. And one thing that's important to remember is that once these start their radioactive decay chain, you can't stop them. It's not like gamma where you stop the ray and the damage stops. They are in you for however long that half-life is. And generally speaking, it's estimated that something, as it decays, it disappears. It takes about 10 times the half-life. So if a half-life is long, it's going to be inside you wreaking havoc for a very long time. There's acute radiation sickness, which we understand because it happens right away and we can see it. It's the chronic lower level emissions exposure that's harder to track and harder to prove. If those internal emitters, or even the gamma rays, they can damage the DNA inside your cell, inside your nucleus of your cell. And DNA damage can cause cancer and birth defects, which therefore cause miscarriage, stillbirth, and problems with fertility, immune dysfunction, diabetes, and we know that it accelerates atherosclerosis, so it causes heart disease. And if it affects sperm and egg, it will cause inheritable disease, which can actually take a few generations to manifest.